This Late Night Linux Family podcast is made possible by our patrons. Go to latenightlinux.com/support for details of how you can join them. Support us on Patreon for access to ad-free episodes and early releases. That's latenightlinux.com/support. Hello and welcome to episode 134 of Linux Dev Time. I'm Joe.
I'm Homolith.
I'm Kevin.
And I'm Andy.
Good to talk to you all again. Andy, you've been thinking about what makes a good commit and how to do it.
Yeah, so I was listening back to the episode with Alan, and we talked a bit about release engineering, and Alan was really keen to emphasize, in order to be able to get your changes onto a release, you need to have good commits. And I thought, actually, we should maybe talk about what that really means, and also what tools we use to help us produce good commits, and also maybe a little bit of why do we care?
I think we've also mentioned in previous episodes, probably way back when, about how learning some of those Git fundamentals can really help you level up your software development career and be kind of a hidden superpower. And I think this ties in really nicely with that, because when you know a little bit more than just Git commit -A or whatever, and just commit everything and push it up and don't even really think about it, when you can go a little bit deeper than that, it really brings projects to the next level. It makes them really pleasant to work in.
Yeah, so a thing that I think about quite often is that I think when I started out working on programming, I thought that I was making a program. And then the more I think about it, the more I think that my day-to-day work is mostly about making small changes to a program, not making a program. Now, if you lose sight of the whole program, you're in trouble. But day by day, what I am actually producing as my work is a change. And so I think it's really important that that thing you produce is good. Partly as just a matter of pride, but also because there's so many reasons why you might need to look back through the history of those changes or rearrange things or whatever, that if they are really good changes that are independent and easy to understand, then your life is just so much easier and the quality level of your software is higher.
And what can make this difficult too is that Git is a power tool. It gives you so many different ways to accomplish similar tasks that can end up with wildly different results on what you're able to do with that later on. So less abstract, what I mean is you can just create single commits that are just jumbles of everything, and you merge that into main without really any thought. And you might think that looking at the repository, looking at the code over the course of time gives you about all that Git can give you. But it turns out if you spend some time crafting your commits and crafting these deltas and changes, that you can end up with something that is not only easier to go back in time to figure out when things broke, if things broke, to move parts around that are not quite yet ready to merge, or even to maintain older releases, much like we talked about with Alan, and being able to pull different change sets forward into other releases. And there's just so many other things you can do when you put some additional thought and time into crafting those changes and kind of how your repository is built up on these blocks.
So, Amalith, if you're looking at a commit in the past, either because you're reviewing it or because you're just looking back over history to figure out what went on, what would make you feel happy? What would make you feel like this is a really good commit? Or alternatively, what would make you feel sad and like this is a bad commit?
Depending on exactly what's happening, what the commit is supposed to do, I like seeing everything needed for that change in one commit. So if we try to test everything, there should also be tests in that commit. If it changes something user-facing and we have documentation for that user-facing thing, it should also include updates to that documentation describing the new feature. Everything related to that thing should be in the commit so I can apply it or unapply it sort of idempotently.
So that's an interesting aspect because, again, as we mentioned, there's so many ways to do things in Git. So you could have all of that in one commit, or alternatively, you could also have each of those things be their own commit, right? Where code is one thing, documentation is another thing, maybe tests are another thing. But then I guess it matters. Are we talking about looking at a commit in history on main, or are we looking at a commit that we are reviewing for, let's say, a pull request, right? Something that we want to merge into main. And my answer to which version of that I prefer depends on which one we're looking at.
That is a good point.
So when it's on main, I like to have atomic commits. Everything related to a change in one commit that I can either revert very simply or remove. But if it's in a pull request or someone's asking me to accept changes, I prefer to see everything very small and broken down into still atomic parts, but the atomic parts that make up that larger change. And then what I ultimately will do is either squash and merge that onto main, or there's a bunch of different ways that we can get it into main. But I like to be able to review those commits independently because I might also have changes that I want made to those particular commits. I might be very happy with the commits except for one. And it makes it easier to review all those various commits. And even one of the benefits of doing it this way is you can say at some point, hey, I'm happy with the base 5 commits, and this would make a good atomic unit. We can squash that and put that on main already while we continue to iterate on the other things. And that gets really close into like a stacked Git workflow. But these are benefits of being able to see those individual components into small commits.
Yeah, I think that's a really good point. Yeah, I think that when I'm a reviewer, basically what makes me happy is if it's small. It's because I don't have to think about too much. But I totally agree. I'm going to, like, what I wrote in my notes before we started was not too big and not too small, right? And if it's too small, so actually things that are related are broken apart into separate commits, then it's really hard to like back something out later or apply that change to some other branch that you need, or even to just understand what's involved. You know, like next time I do a similar change, I want to be able to go and find the commit that did it last time and think, okay, that's all the stuff I need to remember next time.
There are also aspects of this where if I have a series of commits that I want somebody else to accept or review, there are even multiple options for how I get them to review them. I can turn all of this range of commits into a single diff or patch that they review. I can also bundle it up into a series of commits that they will see, a series of commits. Like there's so many different ways in Git that you can ultimately end up at a very similar end state where a reviewer is just looking at all the changes. But these details do matter because it can determine whether or not the reviewer can like step through the commits independently or whether they're viewing like a large blob of something. Like these are all why these little tiny details matter.
And do you have any rules? Like, are there any definite no-nos for a commit?
The subject line can be no longer than 72 characters.
I break that every day.
I maybe do. I try not to. But I don't like seeing the subject truncated in the web UI. And lots of web UIs will put an ellipsis after 72 characters.
Yeah.
Which is directly contradictory to using a conventional commit format, which is where the subject includes like feat, F-E-A-T, or chore, or bug, or whatever. There's all kinds of different like little subject qualifiers, and sometimes they'll even include like the quote-unquote component along with that. So that's even before you've gotten to the like, what does this commit do subject-wise? You're running out of characters very quickly.
I actually find that the prefixes of conventional commits help me write shorter commit subjects because I don't have to say this fixes a bug in yada yada. It's just bug : other stuff.
Interesting.
Yeah, I guess this is mostly in the conventional commit methods that use a component or sometimes a file as well with the commit message.
Sure.
Where it'll be like fix, parentheses, front end, close parentheses, and then : to the subject.
Yeah, so we should make it clear to anyone who hasn't heard of them. The conventional commits is like a standard way of formatting your commit messages. So the message that describes your commit. Yeah, my instinct when I see that is that I just feel like it's constraining and stuff. But yeah, some people really like it. And I can see your point, Amelitha, but definitely about if you said, like, it's actually quite a short, as long as you need to say it's a bug or a feature, which you often do, it's quite a short way of saying that part at least.
Well, the benefit of having those types of conventional commit formats is that there are tools that when viewing a Git log will just pull out the subject line and then they can format change logs based off of ranges of commits. And they can say like, here's all of the commits along with their hashes and even sometimes like parts of the message and throw that all into like a very nice visual change log without having to do the kind of manual parsing of every single commit, which would be very time consuming otherwise.
Okay, here's some of my rules. No white space or linting changes in a change that does something else, right? You can have a change that just does that, but it's got to be separate.
I agree.
And better still, just run the code formatter and the linter before you make any commits so you don't have that problem. Even more hard and fast rule, your commits have to compile and your tests have to pass.
That's an interesting one. I very much agree with the first rule of like stylistic changes need to be, that's the only thing inside that commit. But then the second one of your commits have to compile independently. I would say that for me, that has always been a rule in order to squash and merge that down to main, but at least independently to review, that has never been a requirement, because I've found that it's, at least in my workflow, has been helpful to say like this commit lays the foundation for some major change. However, it breaks things. You kind of have to keep these ranges of commits together. And within base Git, there's not a good way to say like these 3 commits always have to be in this order together. Like base Git just doesn't really have that concept. And I wish it did.
I guess I might allow it if it's just for like working on it before you put it into the main tree. I think the really big motivation for that is that you can use git bisect. And if it doesn't compile, git bisect doesn't work. And just to say what git bisect is a way of searching through your commits to find when you broke the build or when you broke a particular feature. So Git can just automatically search your commits and find exactly where something went wrong. But if it doesn't compile on some of those commits, it just makes life so much harder for bisect.
Well, I think you can pass anything to git bisect, like any kind of command, and it will run that command in succession on every commit and then give you an output.
It's not every commit. It does a binary search through your commits to find the problematic one.
It's the best feeling in the world to have your computer find what happened for you.
Yes.
And if it's constantly actually not able to find things properly because the build is broken on some of the commits, it's sad.
Well, if you enjoy things like git bisect, have you used any external tools? And I don't mean like forges like GitHub or GitLab, but like external tools to Git that sort of build on top of Git. So I'm thinking things like Jujutsu is the big one that's kind of popular these days, but there's a bunch of other tools in similar vein like Git Spice or Git Branchless. Like there's a bunch of different tools that still utilize Git under the hood, but they add some additional features and capabilities on top of it purely at the CLI.
I sometimes use some of the like smaller scripts or utilities or whatever that Git Extras includes. And that might just be Git Lock. If you've got active changes to a file that are uncommitted, you can use Git Lock to make it so your changes to those files are not tracked by Git, so it looks as if you don't have any changes. Those are sometimes useful for just getting a config to work without possibly committing that and including it in your pull request. And there are a bunch of other little niceties in Git Extras. And I've been very interested in Jujutsu. I think I maybe used it for 20 minutes, and I haven't picked it up since then. I don't doubt that it would give me a great workflow and a great experience. I just haven't put the time into learning it yet.
So I've got some colleagues who really like lazy Git, which is not as comprehensive a bigger change as using something like Jujutsu, but it's just like I think it's a TUI for like doing cool stuff in Git, which I definitely feel like I should learn, but I've like learned my own ways of using like git rebase -i, which I really like. And so I haven't quite got to that kind of stuff.
Mm-hmm.
I think learning a tool like NeoGit was almost a game changer for me in the sense that it made things like git add -p so that I can selectively pick what parts of a file or what hunks I want to include in the next commit. But you can do that from your editor. So for me, within NeoVim, you can just select the different hunks and those end up staged for your next commit. That was almost a game changer because it allowed me to be much more selective about the things that I wanted to include in the next commit and kind of craft those commits. And then combined with a tool like Git Branchless, or there's a bunch of other companies out there that will do similar things with a stacked Git workflow where even though base Git doesn't really have a concept of like these commits are together in a stack, there are other tools that do that. So combining the being able to craft individual commits and then combine those commits into kind of a stack, that has been absolutely game changing in my workflow development because I can move these commits around. I can reorder them, work on them independently as my brain decides to hop between tasks. But it has made not only, like, in my opinion, reviewing that code much better, but also given me the ability to think about those code changes in a more natural way.
The tool that sort of turned me on to adding portions of changes was Magit in Emacs, which is what NeoGit was inspired by.
Yes, and that's the tool that I actually started on that got me in this workflow, but Emacs, for whatever reason, just didn't stick with me. So I bounced off that. But when I learned of NeoGit and NeoVim, I was back into heaven because it's very heavily based on Maggot.
I love Maggot. But I don't use Emacs anymore. I use Zed. And Zed has a very similar UI for staging portions of changes as well. I think you put your cursor in a change and it's just Alt-Y to stage it, and then you automatically move to the next one. And it's a really quick and easy way to cycle through all of your hunks and stage just the ones you want.
Most of those tools also allow you to make the hunks smaller. So by default, Git's sort of logic for where it breaks up hunks on whitespace or whatever it is not always the best when it comes to like how you want to craft these things. And a lot of these tools will allow you to select individual lines to be part of the next hunk, which is really, really cool. Mm-hmm. And it's a great feature for how you can very, very easily craft your commits.
I also use Meld for working with gnarly merges sometimes.
I like Meld.
It's a graphical tool that more clearly shows you the changes in a conflict.
Yeah, Meld is excellent. It's usually set up in like 3 panes. So you can imagine like one set of changes on one side, another set of changes on the other, and in the middle is the result. And you can select left or right for like which changes you want to accept. And you'll see them in a visual, like kind of insertion mode. It's really, really cool. And it's great. You can even set up Meld as your Git diff tool so that when you run things like Git diff, it'll pull up Meld for you in the GUI. It's great.
I use Difftastic as my diff viewer, though, because it does some really cool things, like looking at the language's syntax tree to produce a diff that does not include any whitespace changes. So if there are whitespace changes, you can ignore them with Difftastic. And it also gives you a nice side-by-side view sometimes, or just a single view depending on the changes.
I think it's also good at doing things like saying the function arguments changed in this change, rather than just like, the line changed, I don't really know what it was. It's able to pull apart the syntax based on the file and tell you more semantically what the change is, which is really, really cool.
I really ought to get into Difftastic. I'm still using Diffuse, which is still packaged in all the repos of Debian, but I believe it hasn't changed for like at least 5 years. It's just a single Python script that is just a really nice GUI for doing just a simple diff, one on either side. So I feel like we've said a load of things that might be making someone listening feel like it's really intimidating and really hard. So I want to say a couple of things to try and fight against that. So number one, try out these different tools, but if there's like a minimum baseline of stuff you should be able to use, I would say git add -p, which lets you make a commit which doesn't contain everything that you've changed, and then git rebase -i, which lets you pretend you thought about things in a sensible way when actually you didn't at all, because you can change history, not for everyone else, because you shouldn't do that when you've already given your changes to other people, certainly not when they're merged onto the main branch. But before you give your changes to other people, I find it an incredibly constructive and helpful thing to do, to take the complete mess that I've made and rearrange it into nice, simple commits that make real sense. And the reason why I find that so nice is that it makes me understand that I actually understand what I've done, and it's not just chaos.
This is a part of development that I don't think gets a lot of attention. So when you put up your pull request or you ask somebody to review your code, a lot of times they're seeing the mostly final result of what you have come up with. And while there might still be minor changes and things that they'll ask for, they're still seeing like the commits probably in the order that you want, with the messages you want, and all of those sorts of things. But that's also not like how normal development happens. And I think that's one of the things that leads to development being somewhat intimidating is like my regular workflow. I have git add -p to add random parts of it, or whether I do that in NeoGit, doesn't matter, but I'll have all this, and I create checkpoint commits constantly, just random, to kind of keep track of things. And then once I think I'm ready, or I'm getting more close to ready, I will git rebase -i to squash down some of those commits, reword them, move them around, do all those sorts of things, and I'll like work towards a final product that I eventually push to the remote for review. So there's a lot of like messiness involved in the middle. Like we don't, even when we use all of these tools, or even whether they be external tools or just bare Git, there's a lot of messiness involved, and that's okay. There's ways that you can take that messiness, tame it, and get it down to something that is reviewable and looks really good on the end. And that also, like I said, that really ups your game when you're working collaboratively with other developers.
Using git rebase is like combing your bed head out.
But yeah, I think it's actually going back to what I was saying at the beginning of, don't just think of it as I'm building a piece of software. What you're doing that day is building a change or a series of changes to a piece of software, and that's your output. And that means, like, I've definitely worked with younger developers who can't understand why I'm getting them to waste all this time making their commits good when they've already done the work. And my point to them is, if you've just written a big ball of mud, you haven't done the work yet because you haven't actually arranged your thoughts into actually, I can understand what I've done and explain what I've done to someone else.
And something like a git log or git blame later on, I can't count the number of times that I've looked at one of those tools and then been super thankful that we had different processes or standards around how we commit, because it makes it so much easier to see, like, okay, I see why this was done and in what way. And you can kind of jump back into history and see these things. Like, those are excellent tools to also learn git log and git blame. Yeah.
And by the way, I should mention one other thing that I do from time to time is if I have a set of commits or just code that has just got completely out of control, and I get it to the point where it's working, but the history of it is just a mess. What I will do is just git reset main or something like that. So what that does is it doesn't change the code in your working directory at all. All it does is throws out all the commits. So now it's like you've just got a massive diff against whatever the main branch was. And then you can git add -p your way to having a sensible set of commits.
I sometimes take that approach, but I always worry I'm going to end up in a situation where I can't tease apart two things.
Yeah.
Because they're just a little bit too close together and Git can't quite separate them and produce the hunks it needs in order to do a partial add.
The way I've found to deal with that is in stacked Git workflows, where you can kind of have this ball of mud at the beginning. You can tease out the base layer, whether that be multiple commits or not. Like, you can tease that out, create a new branch on top of that, do kind of the same sort of thing, find another ball of mud, but instead of going all the way back to main, you're only going back to the base branch. And you can continually do this until you have several branches, several stacks of commits on top of each other that you're happy with. Now, at that point, you have to decide, do I want to make these all one branch for a pull request? Do I want to have multiple pull requests? Like, that's a different conversation, but you've at least kind of worked your way progressively through smaller balls of mud into something that is viewable.
Yeah, I frequently end up with like about 3 or 4 pull requests, each of which consists of multiple commits that I'm trying to get merged, and they build on top of each other. And I wish I had a better way of managing that. So I need to find out about some of this stack stuff, Kevin.
Oh, definitely look into Git branch lists. And then depending on how you feel about the companies involved, there are tools like Graphite or GitSpice that will handle some of the like pull request details and rebasing and removing stacks around for you, just using Git under the hood. Git branch lists is also written in Rust as well. So, that's another reason to look into it.
And that used to mean it was a good project.
It's not at all essential for working with Git, but since I figured out how to use Git work trees, I've found that I really, really like them. When I'm not using Git work trees and I just have the project in a directory and I have to switch between branches inside that project, it feels like I have a workspace with a big table, and as I'm working, I can clutter that table with whatever I like. But then before I can switch to another branch, I have to clean that table off and put everything away and make it look nice before I can switch to another branch. While with work trees, it's like buying a new table for every branch. I can just leave it exactly as messy and immediately switch to whatever else. I don't have to worry about stashing things or making a work in progress commit. It's just exactly as I left it.
Interesting. Yeah, I make a lot of work in progress commits, and sometimes I stash things, but I always worry I'm going to forget them.
Yeah, I used to stash a lot, and that drove me to work trees.
I think what we're saying, listener, is learn a bit more Git and you won't regret it.
Right, well, on that profound note, we should probably get out of here. We'll be back in a couple of weeks, but until then, I've been Joe.
I've been Amalith.
I've been Kevin.
And I've been Andy.
See you later.